Okay, let's look at algebra with two unknowns. And the first way I have for solving this is dependent upon this earlier column, and it's solving systems by graphing. Now, for the teacher's convenience, I have, let's see if I can get at it. I have created a worksheet, and I think I can bring it up here. A worksheet, and I have typed in it. This is not part of the worksheet. These things right here, they're all just y equals blanks when it starts, but I wanted to have them solved. And there are some equations in two unknowns. And the students, first of all, have to get them into the graphing form, which means solving for one y. So if you take this equation and you solve it for one y, you get y equals, I think I've done that wrong, y equals 4x. It's not negative 4x. Y equals 4x minus 3. And I hope this one's right. 4 equals, y equals negative 1/2 x minus 7.5, I think. And so you'd have to go through these and solve them probably before you come to the lab. Solve these for 1y would be a good idea. And oh, look, I have some child abuse down here with fractions. And then we want to look and see how we would go about solving this. Now, you can do this on your calculator, but it's going to be a little bit easier here. Now, what we're going to do is we're going to put this equation, y is equal to 4x minus 3. I'm going to put 4x minus 3, and I can choose what color I want to use. And I'm going to graph that in red. So y equals 4x, and now I'm going to try to find my sheet again and put this other one in, minus negative 1/2 x minus 7.5 minus 0.5 x minus, I hope I said minus 7.5. Let's just double check that before we go on here. Minus 1/2 x minus 7.5. And let's make that one in blue. Graph. So now, every point that would make the first equation here, the red graph, true, lies along this red line. There are an infinite number of points that satisfy this first equation. That's why this is called the equation of a line. See how linear has the word line in it? So any point that you went along here, so like see right here we have a lattice point, and it's 2, 1, 2, 3, 4, 5. 2, 5. If I put a 2 in here, that's 8 minus 3, 2, 5 works on this line. And you can check any of the lattice points that it goes through. But all the fractional points it goes through too. The infinite number of points along this red line is the graph of this first equation, the red graph. And all of the points along this blue line are things that satisfy the blue line. There's an infinite number of x's and y's that make that true. But there's only one point that makes both equations true. So that point is negative 1, 1, 2, 3, 4, 5, 6, 7. So if I trace the value of the mouse, I can bring this right here. Oops, except I've got to get it right on the lattice point. Negative 1, negative 7 is the solution to this system, and we found it graphically. I hope you understand that. Thanks.